So, without further ado, let me introduce the first speaker of today. Please join me in welcoming Radu Dobrinescu, Senior Partner Solutions Architect at AWS. Radu has been working in technology for 17 years, spanning different technologies and roles. Currently, he is helping partners design and deploy innovative products and services that leverage the benefits of the AWS platform, with a special focus on containerized workloads and DevOps practices and tools. In this session, Radu will share the what, why, and how of MLOps on AWS, exploring the features in Amazon SageMaker pipelines that help us increase automation, track data lineage, catalog ML models for production, improve the quality of our end-to-end workflows, and support governance. Also, he will show us how to use SageMaker projects, which provide MLOps templates for incorporating CI/CD practices into machine learning pipelines. Thank you for joining, Radu. The stage is yours.
Thank you very much for the introduction. Thank you all for attending, and thanks eSolution for this opportunity, especially. So as Cesar mentioned, today's first talk will be on machine learning operations, and especially how to implement these practices on AWS. And I'd like to start with a brief introduction of machine learning, and most particularly about the business impact that machine learning has today. And we see that from predictive text, from language translation applications, the way that Netflix recommends what shows to watch, how social media feeds are presented to us, everything contains machine learning, right? So I think that talking about the business impacts, obviously all of these on the slides are valid, but it's almost a cliche in today's world to say that machine learning is in all aspects of our life, right? So basically a lot of use cases, but no matter what the use case, the machine learning process is pretty much the same. So very simplified at a very high level, the process looks like this. We basically start from a business problem, and then we try to frame that as a machine learning problem, right? As soon as that is done, we move on to a data engineering phase, where we collect the data to support our machine learning system. We integrate that data, we do some data processing, can be cleaning, can be transformations. We then run some ad hoc analysis, and we come up with features. So we do feature engineering. And then we move on to a phase of building the model, where we actually train the model, we tune it, we evaluate it, and this becomes an iterative process, right? So we run experiments until that model generates the performance that our business needs. Once we reach that point, we move on to a deployment phase, and the model will be deployed to generate predictions, what we call inference. And we move on to a continuous monitoring phase of the model. Right? So this is very broadly the process for machine learning that we apply in all use cases. And we see organizations that adopt machine learning being in one of two phases. The first phase, which is also called sort of a pilot phase, is actually the phase where the organization wants to answer one question. And the question is, can we use machine learning to solve this particular business problem, right? So this phase is actually more exploratory in nature. It handles a lot of experiments, training the models, tuning the models, and so on. So the main focus is actually on the machine learning code, on running the experiments, collecting data, and basically how to evaluate these models. However, as the business embrace machine learning, so if the answer is positive, if machine learning can be used to solve this particular business problem, then the organizations will find that these type of manual workflows will become bottlenecks for innovation. So they will want to move into a productionizing phase of the machine learning process. And this is where actually the focus shifts to the operational side of things. So the machine learning code itself takes a secondary step, and then the organization is focused on all the other operational details of productionizing machine learning. But there are challenges to that. So machine learning workflows can become complex, So building them and troubleshooting them is a challenge, it is effort intensive. Managing the models can also be challenging because you need to version, you need to collect data about the performance of each model. And with machine learning, as opposed to DevOps, where we need to version and version control code, with machine learning, we need to do that for code, for model artifacts, and for data. And we need to do that while we are also meeting the regulation requirements and compliance of the company. And all these challenges are actually reflected in the overall trends that we see in the industry. So even though in the last decade machine learning has been very popular and has gained a lot of traction, the focus has been on building the machine learning models, right? And only now the productization, or moving on to an operational side of machine learning, even just now is becoming a thing. And we actually see that only a little bit over half of the proof of concepts, the POCs that are done on machine learning, make it in production. And when they do make it in production, it takes 9 months to have a model in production. However, it's now estimated that about 75% of organizations will shift from just piloting a machine learning system to moving into production. So even with all these challenges, the way that organizations will manage to do that is by implementing MLOps, machine learning operations. And this will allow them to gain agility, to run experiments much smoother, and to move faster with their models towards production. This will enable organizations to scale much better and to improve time to market. There are different tenets that stand behind MLOps. These are flexibility, so engineers should be able to use whatever machine learning framework they want with MLOps. Reproducibility, so they can reproduce different models and resources. Scalability, auditability, we'll see that with lineage tracking and so on. So now that we introduced MLOps and where they stand, just a few details about this discipline. And the discipline itself stands at the intersection of 3 domains, which are machine learning, data engineering, and DevOps. And MLOps, similar to DevOps, let's say, is a series of best practices, and actually these rely on people, technology, and processes. And we see the value add of building machine learning models at the intersection of these 3. But today, the focus will be on technology. So let's see what makes an MLOps platform. And at the high level, this is made up of 2 technology components. One of them is a task orchestrator, and this is the typical workflow solution that you create to manage workflows. Think of CI/CD pipelines, and usually all that workflow is represented in a DAG, right? So in a directed acyclic graph. As in actual solutions for this, you can go for an AWS native solution, such as SageMaker pipelines, or the AWS step functions, or you can go for open source solutions. So MLflow, Kubeflow, or Apache Airflow. These are all valid solutions to implement this orchestrator. And the other part of MLOps is the actual machine learning platform, right? So allowing you to run all the actions in that machine learning process that we talked about. So from data processing to building your model, training your model, evaluating, and so on. And again, you can have 2 approaches here. So one of them is to do it yourself, so to build your machine learning platform, and you can leverage, let's say on AWS, you can leverage deep learning containers or deep learning AMIs, images for your virtual machines, and just use the services for running virtual machines such as EC2, or use containers orchestrators such as Kubernetes or the Elastic Container Service, or you can use an ML platform, which is SageMaker, AWS SageMaker. And since we're talking about machine learning on AWS, just a brief review of what are the possibilities of running your machine learning workloads on AWS. And the offering is split actually into 3 main layers. And at the bottom, you see the machine learning frameworks and infrastructure. which is basically addressed to machine learning experts, so practitioners that do have deep expertise in machine learning, and they only need to either choose their framework, TensorFlow or PyTorch or Apache MXNet, and then actually use the infrastructure, right? So they can choose to use GPUs, they can choose to use deep learning containers, and the call out here to the Amazon developed chipsets for inference and for training, which actually bring a lot of performance and at a lower cost. At the top layer, we have AI services. So these will not give you the flexibility of coming up with your own models. The model is embedded, is already developed, built, trained by Amazon. But these services are very easily integratable in services just by calling APIs. So a good example here is recognition for computer vision, where you can recognize objects in videos or images, or a service to translate, to extract, doing OCR, or text-to-speech or speak-to-text with services like Poly and Transcribe. So these are just callable by APIs, and you can very easily integrate them, and you have machine learning capabilities in your applications. And then at the middle layer, we have Amazon SageMaker. And SageMaker is actually a complete offering that will cover all the different activities of your machine learning development, from data collection and preparation all the way to the model deployment and monitoring of that model. So SageMaker is actually a collection of services and capabilities specific to machine learning. So let's have a look at some of these services, especially in the context of machine learning operations. And the first one to note is SageMaker Studio. And Studio is actually a web-based IDE, an integrated development environment, specific to machine learning solutions. Again, it's something that you can use to train the model, to tune the model. You can monitor your model with all the services included in SageMaker Studio. So think about it as a single unified visual interface that allows you to write and execute code in one or multiple Jupyter notebooks, allows you to prepare data for machine learning, to run ad hoc analysis, and then to build and train those machine learning models, eventually to deploy the models. There are different deployment options, and to track and monitor the experiments for machine learning. So this would be just the interface that you use when you develop these solutions. Then we have Amazon SageMaker Processing. And again, this is a managed experience on SageMaker to run data processing workloads. So this can be feature engineering, data validation, data preparation. A good example here is actually splitting the data. And basically what you can do with SageMaker Processing is choose your environment. We can see here an example of a container, and then to run the actually pre-processing of data. A common pre-processing action is to split the data that we have into train, validation, and test subsets, data sets, that we can use then to train the model. So this is an example here. And with SageMaker processing, you can actually use different platforms for processing, such as Skylern and PySpark, or you can use framework processors. And these are supported, so Hugging Face, MXNet, XGBoost. Or you can have the option to bring your own containers as well. So it's very flexible on how you do processing. Very important for machine learning operations, SageMaker pipelines. So you remember that we went through that machine learning process in the beginning where we saw data collection, preparation, and then feature engineering, model training, tuning, evaluation, and so on. Everything, all of those steps can be described in a pipeline. And we use SageMaker pipeline for that. So it's basically just a series of interconnected steps. Again, you will see something defined as a DAG, this directed acyclic graph that you see with typical pipelines. And whenever you define it, basically you will have a series of steps. First step here is Athena to actually pull the data from some sort of data lake, and then you are moving to the first phase, which might be pre-processing, right? And pre-processing, again, we saw the example, right? So you can just define your containers when you want your pre-processing to run. And by the way, if you do have very large volumes of input data, you can actually use distributed processing with SageMaker processing. You describe the process, again, it's just an example of splitting that data into multiple data sets for training the model. And then it's just a matter of including that step in your pipeline definition. So the pipeline definition, again, has some attributes, and then it's the order of steps that you've defined previously. So this is how SageMaker pipelines looks at a very simplified model. We then have a service called Model Registry, and basically this is a metadata store for your machine learning models. Once you evaluate the model, once the model is performing at the expected level, then you can register in the Model Registry. And this actually has capabilities around versioning, around manual approval for your model, so they can be promoted to production. Underlying the Model Registry is Amazon S3, where the artifacts are kept, but the Model Registry is just a top layer, which includes metadata and versioning for those machine learning models. And then we have SageMaker projects. And before explaining what SageMaker projects is as a service, we'll have a look at this diagram, which starts basically from a model build repository. So this is AWS commit in the slide, but this actually supports also Bitbucket and GitHub and GitLab. So you can use your own code repository for that. And basically, the solutions that we see implemented for MLOps usually go with two repositories. There's one for the machine learning model. So this is a repository where you can actually use branches to implement new features. And this is a repository where you have all your files that define the machine learning pipeline. So whenever you bring on a new step, basically with a push, a commit and a push to this repository, you will have a code pipeline kick in. And this will actually, again, go through the steps of validating the repository structure. It will it will test the code, and then it will run the actual machine learning pipeline. And if you remember from that machine learning pipeline, basically the last step is to evaluate the model, and if the model meets the requirements, it will be saved in the model registry. So once we have the model which is fit enough for production and is saved in the model registry, we actually move on to a deploy pipeline. Again, this is supported by another code repository, which in this case is called commit, but can be other solution. And basically, here, once we have the model committed, saved in the model registry, then we have an event triggered in event bridge, which will kick off this new pipeline, the deployment pipeline. And this is basically just a pipeline that deploys the model in a production environment, which means for real-time inference, for example, we will have an endpoint where we can call that model to run predictions. So you can see that this is quite a complicated slide, I would say. A lot of moving parts, a lot of components, and basically SageMaker projects allows you to create a template from that. So there are out-of-the-box templates that come with the product, and you can just simply clone a repository in your own project, and you will have this sort of architecture already in your accounts, and you can start using it. Obviously, once you customize it according to your use case, you can save it as a template, and then you can replicate this template many times. So think of CloudFormation or infrastructure as a code for MLOps solution. This is what SageMaker projects does. And then Amazon SageMaker also includes capabilities for lineage tracking. And basically that means that SageMaker will automatically create and will store information about the steps in your workflow. Right? From data processing all the way to model deployment, you will have all the information, all the metadata and experimentation data of the artifacts. So this will include any artifacts that you already have, such as models and experiment outcomes and so on. And you can also create custom entities to be, let's say, for these custom entities to save all this information as to track lineage. Also with lineage tracking, there is a query support. So basically, you can run queries. Here you have an example of basically finding all the data sets that are associated to a certain endpoint. So through all that machine learning process, you can actually find where you started, the data sets that supported the machine learning process, and you can associate them with the endpoint where the model is running, right? So you can figure out all the correlation because SageMaker lineage tracking keeps track of this graph, all the resources, and all the data and metadata associated to them. So basically, this is the way to actually run any audits and to maintain compliance and regulatory compliance with the solution. So now if we were to bring all this together, and if we were to see that initial process, the generic process and simplified ML process through the lens of the AWS services, it will look something like this. So there would be an initial data preparation phase, and you can do this either with SageMaker Data Wrangler, which is basically data preparation, data cleaning, data transformation in a visual way, so you don't have to write any code. You can do it just by using the web browser, or by using SageMaker Processing Job. And there's also the feature store where you can actually store the curated features once you run this data analysis. Typical inputs into this phase are raw data, because you are just doing the preparation, data processing code, and some feature. And as output, we've seen the example of the splitted data sets. So a data set for training the model, and then one for testing, one for validating that model. And this will serve as input for the next stage, which is running experiments for your machine learning models. So this means that you will train a model, and then you will evaluate the model, see if the performance of the model is what you expect as from let's say a business requirement. If it is what you expect from the business requirement, then you will move that model to the model registry. And basically we see that there are other outputs being generated, such as the model artifact experiment, an output of the experiments, and the model artifacts for the candidate, so the one that meets the production requirements, right? So these are all versioned and traceable for auditability. Once we have identified this model that is fit enough for production, we can move on to the deployment stage, right? So SageMaker deployments, which can then deploy the model to multiple target environments. And this is similar to DevOps, where we build once and we deploy to many environments. The same thing, we train the model once and then we can deploy it to different environment targets, pre-production, production, real-time inference, batch inference, and so on. And there is also the SageMaker model monitor, which basically allows us to have an ongoing monitoring of the model's performance, right? So we make sure that if there is data drift, if there is concept drift, model drift, then we are, first of all, alarmed of that. And then we can also trigger the process all over again. So we have to train the new model based on the new data or whatever is changed in the system. So this is how a typical MLOps process works. Now, obviously, you might have all the services included in a particular use case or just a subset. It depends, right? And moving on from this theoretical MLOps pipeline, let's see what is actually happening in the real world. Because companies that will adopt this MLOps technology will usually have an incremental approach to it. So it will not go directly through that, implementing all that pipeline. And this is actually seen across a maturity model, which has 4 stages. There is an initial phase, there is a repeatable phase, what we call a reliable phase, and then a scalable phase. In the initial phase, it's very similar to what we talked about the pilot phase. Basically, it's just a matter of experimentation. You want to see whether machine learning is a good technology to serve the business needs. Once you decide that, yes, machine learning is a good technology for your business needs, then you want to move on to the next stage, which is repeatable phase. So you want to have the technology, the platform that allows you to move on very fast with your machine learning models. Then you want to have a reliable phase. You want to make sure that you are properly testing your models before you promote them to production. So you move on to pre-production, production, and you have this pipeline to promote different models to different deployment targets. And then you have the scalable phase, which actually allows you to templatize all this platform and then use it for multiple machine learning use cases. So let's have a look at all these phases, but now on a architectural diagram, so you can also see the services and how they relate to each other. In this initial phase of running the experiments, basically there's just the data science team, which will run machine learning workloads, right? They typically use SageMaker Studio. They will write and execute their code in some Jupyter notebook. Maybe they use Data Wrangler for data processing or some other processing job. Maybe they use some other services like EMR for data ETL, extract, transform, and load. This is the experimentation phase. So once they are able to train and tune and deploy a model, basically they will need to come up with a way to do that in a repeatable fashion, which already introduces pipelines. So here we want to have CI/CD, we want to have control over and consistency over how we actually develop those models. So here there are a couple of new components in this phase. First of all, in the initial phase, all the data is actually loaded as batches of data that we use then to create those models. When we move into a repeatable phase, we introduce this data lake component. And basically, this will be managed, operated by data engineers. So it's also a separation of concerns, a separation of duties. All the data will fall in the responsibility of data engineers. All the data will be ingested through different sources from on-premise, from other systems into this data lake, which sits at the center of all machine learning use cases. So this will typically be S3. There can be a feature store here in this, and this is governed by a lake formation, which basically is data governance. This is how we control the access of all the other external systems that are pulling data from our data lake. And we also separate that into a separate AWS account. Next, we have the team of data scientists, and basically there's not much change for them in this phase. The only change is that for now the source of the data does not really come from batches of data. It's actually, let's say, more production data that is coming from the data lake. And then we have a lead data scientist who is actually responsible for promoting different models to production. But how are those models promoted to production? Well, by implementing the next phase, right? And here you can see basically a development account, which includes the machine learning pipeline. And this is the exact pipeline that we saw earlier with pre-processing, model building, model training, tuning, evaluating, post-processing, and so on. So this is the pipeline in the development account. And we also have a tooling account, which is basically all the CI/CD pipelines, repositories that we've seen earlier, right? So the actual machine learning code, the artifacts, and so on will be kept in these repositories. And in the data lake, we only have the data. So by now, we basically implemented machine learning pipelines. So now we have a consistent process to go through all this machine learning process. We are moving from simply doing ad hoc work in notebooks to a verifiable process that can be repeated every time. So it's a lot faster to run experiments and to develop new performing models. In order to do that and to have an efficient way of implementing that, we also need to standardize the repositories. And remember that we had two repositories. One was for the machine learning model building, and the other was for the machine model deployment. And basically, this is a good example of how to standardize those repositories. For the building and training of the model repository, you have a root folder where you store the algorithms, and then all the steps of those algorithms described, pre-processing, training, and so on. Then you have another for the pipelines, where basically you are just describing the pipeline itself, what are the steps, and you are referencing the ones from the algorithms, and then you have your notebooks. And similar in the other repository, which is for model deployment, you will have application configuration, infrastructure configuration, basically the targets for your model deployments. Equally important to standardizing these repos is standardizing the data structure. So remember that we had that data in the data lake, and this is all the data that supports your machine learning system. It's important to standardize that for auditability and also for the collaboration between, the data engineering team, data science, and machine learning engineers. And this is another example. Basically, you have, if let's assume that we have a single bucket in that data lake, all the input data is pushed into that bucket. And then we can split if we have multiple machine learning use cases. Let's say we are doing different solutions where we want to implement machine learning. We can split onto that. We can then trigger the pipeline, and this trigger of the pipeline would create a new subfolder which has the name of the build ID. This can be the ID of the pipeline execution, it can be a timestamp, it can be whatever we configure it to be. What it will do, it will just copy the input and the code from the repository, and then it will run the pipeline, which will result in another folder that has ML pipeline outputs. And in this folder, each step will have its own output data. So it's a great way to actually audit all the artifacts, all the data that is generated through a single run of that machine learning pipeline. Moving on to the next phase, which is the reliable phase. So for now, we've seen that we are confident machine learning will answer the needs of our business. We have already implemented a consistent process to train, develop, deploy the models through pipelines. But now we are thinking, okay, how do we use those models? How do you run inference against them? And we need to have a reliable way of doing that. And so we introduce a pre-prod environment where we deploy our model. Basically, what this will allow us to do is once we have the pipeline running, once the model is evaluated and is performing correctly, remember it is copied on the model registry. And then we have the option to go to SageMaker and manually approve this model. If it is approved, it will be deployed into this pre-prod environment where we can run different tests. So this can be integration tests, unit tests, machine learning tests. We can run batch inference, real-time inference, and see whether load tests, and see whether the model actually performs. If it does, then again, we will have a manual approval step, which we can actually execute in code pipeline, and this will promote the model to the production environment. Production, which is very similar to pre-prod. So now we have the machine learning model, which is proven to solve the business. We have the consistency of the pipelines, but you also have a reliable way of promoting these models to production through deploying them into a pre-prod environment when we can run tests, and then promoting them to production where we can open it to the world. There is also one thing to consider into how the data is integrated, or how the data moves between these different machine learning operations platform environments, development, pre-prod, prod, and the actual data lake. Right. So from time to time, these pipelines, in order to trigger these pipelines, they will need to be hydrated with some data. Right? And for the development environment where we are training the model, we can just pull that data. That is why you actually saw that Athena box in the pipeline. Athena is basically a service that can run SQL on top of S3. Whether that is structured data, whether it's unstructured data, you can pull data from S3, from the data lake, and you can serve it into the pipeline, use this data to train your model, evaluate it, and so on. So for the development environment, this is what you would do. Then once you move to pre-prod and prod, basically depends on what sort of inference you are running against those environments. If it's just real-time inference, then you are just sending a request to the endpoints, and that means that the data that you want, you can send it with the request as well as a payload. If it's a batch inference, then you need to send batches of data to your MLOps pre-prod and production environment. And this can be done, again, either by running, let's say, on a schedule, pulling the data from the data lake and running batch inference on that. And this can be with EventBridge, where you can schedule every 5 minutes, every 5 hours, every 5 days, whatever. Or it can be triggered automatically when new data is being stored on S3. So when new data arrives, in the data lake, you can trigger this event. The event can then trigger a pull from the data lake. And then there is the other solution, which is less common, that you can actually push from the data lake data into the pre-prod and prod environment. But this kind of contradicts with that separation of duties, where the data scientists and the machine learning engineers will handle the MLOps platform, and the data engineers will handle the data lake. And then there's the scalable phase. And the scalable phase, this is quite easy. Basically, all the things that you've built, you can templatize, and you can reuse those templates to create other platforms to support other machine learning use cases. So basically, this is fully supported by the SageMaker projects service. And just to give you an example of from the real world, we have this customer, NatWest. NatWest Group is actually the largest commercial and business bank in the UK. And basically they are support, I don't know if you can see the logos, RBS and Royal Bank of Scotland and so on. But basically they have quite a large presence. They have about 60K of staff worldwide, and they are heavily invested into machine learning. And now they are operating about 3,000 machine learning models. Their challenges before implementing this MLOps approach were basically how to handle the different data sources from on-premise, and they had to deal with a lot of silos in terms of data, but also people and teams. They also had quite old technology in terms of machine learning, so they had to actually renew and to enhance all of these environments. Data was difficult to discover, so they didn't know how to pull all the data and bring it together in a sort of meaningful way from across different silos. Also, governance of and access to that data was difficult to manage. And basically all of these challenges translated into a long time to production, right? So going to market was a difficult process for them. And what they did, basically they fully went to an approach such as machine learning operations, and they did that on AWS. So they used all the services that we've gone through. They reduced cost of processing by using the SageMaker processing and distributed processing. They used automated pipelines, and they were able to very quickly experiment with new models, train them, evaluate, and deploy those models. If we remember that adoption roadmap, basically going from the initial phase to the scalable phase, this is where NatWest Group started, and this is where they are right now. But actually, more meaningful, I guess it's important to look at the business metrics that they were able to achieve with this process, right? So their delivery of end-to-end machine learning solutions went down from approximately 12 months, 1 year, to 3 months. And yeah, they simplified a lot the way they are able to deliver machine learning models. Basically, the one thing that is important here is to look at this machine learning environment creation, right? So whenever they had to onboard a new team that needed to create their own platform to run a machine learning use case, what they did initially took them 5 days to provision all the resources and to come up with this platform. Now, by using this approach, by using the SageMaker domain, by using SageMaker templates, so the SageMaker projects that we've seen, it templatizes everything. By using service catalog and infrastructure as code, they were able to bring that to less than a day, and actually everything can be provisioned less than 2 hours. So in terms of technical platform, it's provisioned in less than 2 hours, and you can see how much each step will take. And they were able to onboard this new team within a day compared to 5 days previously. So, as a summary in the end, MLOps fully supported by the SageMaker offering and brings all the advantages of this purpose-built tool for machine learning workloads. Automating your workflows for machine learning, monitoring the quality of the models, and basically moving a lot faster with machine learning, moving from a pilot phase of just experimentation to fully embracing machine learning and implementing it across the business. Thank you very much for your attention. I hope that was not too boring. If you have any other questions on machine learning or AWS or partnerships with AWS or anything like that, feel free to reach me on LinkedIn or directly on email. Happy to get engaged in any of the conversations. And I think we still have about 1 minute for questions, if there are any questions from the room.
Well, thanks for the presentation. It was really informative, and clearly the system is really good. Can you just quickly outline what are the main limitations of the system and the known problems?
Of a system overall, or a particular system, or
Of SageMaker.
of SageMaker?
Right.
I mean, it depends. As I said, SageMaker is a suite of offerings and services. I would not see it as a service with limitations. I would probably see it as a suite of services that will enable you to handle, manage machine learning workflow from end to end, right? So as soon as you want to do machine learning workflows, machine learning use cases, let's say, and implement them, then you have this suite of products that is SageMaker. And you can start with, let's say, data processing. You can do data collection. Well, data lakes usually are not a part of SageMaker. They are stored in S3, right? So SageMaker would be a client for a data lake, right? But then you kind of have all these components or modules of SageMaker or even services, and obviously each of them will come with their own limitations. So each service within AWS has some limitations. Now, this can be, known limitations, which are soft or hard, or limitations that may be in terms of feature, right? That maybe they are not implemented yet, or are missing. For now, SageMaker is the most complete suite of services to support machine learning use cases. Obviously, there are limitations, but we'll have to, discuss into each module, particularly what are. I cannot really think of a.
So what you're saying is that the system itself doesn't have limitations. Its limitations are in the infrastructure.
So they would be very, very specific, yes. And again, each AWS service will have limitations in the sense of quotas, right? So if I'm creating a new AWS account now and I want to push it to the limit, I will meet some limits. So I cannot just absorb all the AWS infrastructure for myself. Now, there are guardrails for that, right? If I hit those limitations and I do have a valid business case that I would need more resources, then I can just raise this first limitation, which is usually just a soft limit. So I can call AWS or write AWS or open a ticket in the console. I say, well, I need more resources. And then I will be asked just to provide a description. What is my business case? Why do I need more resources? It then will be approved and I can use those, yeah.
Thank you, Radu. Any other questions from the room? If not, maybe you can have time for one question. I have one. So considering a mature build and deployment pipeline, what would you say would be the main reason for it to fail? So the component in it that right now gives you the most headaches?
So again, it can be failing the pipeline itself, right? So an execution of the pipeline, you mean?
I was thinking of a specific component in the whole pipeline.
I mean, it's just like if you think of a parallel with DevOps, right? The whole point of having a pipeline is to have this reliable process where you want your code to move from development to production, and you want to catch as many bugs as possible by moving through this pipeline, right? It's the same with, pretty much the same with machine learning ops, except that you don't move just code, you actually move through this pipeline code, model artifacts, and as well maybe some data, right? So you want to make sure that all of these are properly versioned, are tested before moving to an environment where they are deployed and they can be used. So now, basically, it can fail at any step, But it depends on what the input data is, it depends on the processing jobs that you are running, it depends on the test, right? And basically the whole idea is to have this repeatable and reliable process so that you catch these failures and you don't promote them to a production environment. I hope that answered your questions. I don't know if I got it right.
Yeah, mostly. Okay. Thank you, Radu. If there are no other questions.
Really quick.
Yeah.
You mentioned pre-prod. Is there any difference between pre-prod and staging? You know,
No, I mean, you can call it whatever you want. Basically, yes, it's a staging program.
You weren't trying to make a difference.
No, just an environment that is as similar as possible with production. Okay, thank you all and enjoy the rest of the event.
Thank you.